Hello, I'm Dr. Cogburn, and I specialize in tutoring students in statistics in Excel. And in this short video, I'm going to show you how I approach statistics problems using Excel with an emphasis on clear explanation and practical application. I'm looking forward to working with students who want to strengthen their skills and confidence. Okay, so here we have a problem in statistics that asks us to use the single factor ANOVA in Excel to solve this problem. So here's what the problem says. The problem says the following table contains a random sample of 40 women partitioned into three groups. Group 1 is ages below 20, Group 2 ages 20 through 40, and Group 3 ages over 40. The values in the table are systolic blood pressure levels. And so here's the hypothesis test. The null hypothesis is that mu1 equals mu2 is equal to mu3. In other words, the three treatment means are all equal to each other, and there's no difference based on the age groups of the participants in this study. The alternative hypothesis, however, says that at least one of the treatment means is different. Not all of the treatment means need to be different. Just one of them needs to be different from the other two. And so we're asked to use the Excel analysis toolpack to create an ANOVA single factor table and then answer the question, is there sufficient evidence to support the claim that women in different age categories have different mean blood pressure levels? And we'll give our decision. So one of the challenges when we have data and we don't have a data file is, get my data file here, sorry. One of the challenges when we don't have a data file is getting the data into Excel in the right format. So you can see we have three groups that have uh, different numbers of participants, and so there's not a lot of data here. We could easily enter this data and create the data table manually. But there's times when we have a lot more data than this. We may have several hundred participants in each group, and that would be a lot more difficult to deal with manually. So what we want to do is copy this data and transform it so that we can create the data in Excel using a few keystrokes. So I'm going to copy this data just like you see here. I'm going to copy it. I'm going to hit Control C and copy the data. I'm going to go to my Excel sheet, and here's my Excel sheet. I'm going to expand that so we can see the entire Excel sheet. And I'm going to go to B2 here, and I'm going to go home, and I'm going to paste, not hitting Control V or doing a standard paste. I'm going to do a paste special, and I'm going to paste this data, not in HTML code, but in Unicode text. And when I copy that, it's a little bit easier, it's going to be a little bit easier for me to deal with when it's pasted this way. So there's a couple of things I've got to do to get this data transformed into a form that I need. If you notice the group one data, I'm gonna right click on column C and just insert a column there. And you'll see that I can't insert a column because all the data is in column B. So I'm going to have to use the data feature text to columns to expand this table and split these columns into individual columns. So let's do that. I'm going to start by just selecting the entire row B because that's where all the data is. And I'm going to go to data and hit text to columns. And I'm going to use either the delimited method or the fixed width method to separate these columns. I may have to do this a couple of times to get it right, but let's start with the fixed width. I think the fixed width is going to be easier for us to deal with than the delimited feature. So if I click on fixed width and hit next, you can see that group one is broken up into a column. And go back up here, uh, is group two and group three are overlapping. So I'm going to need to move this arrow to where it goes just before group three. And I'm going to have to leave this arrow where it is, this line where it is, because it's overlapping the number. So I am going to have to do this more than once. So if I hit next and finish, this separates the data into one one column, two column. We have three columns here, it looks like. Let's see. Yeah, it looks like we have three columns now. So this is a little bit easier. I'm going to go ahead and manually move these numbers over to group two. So now I've got group one, group two, and group three. So all I need to do now is just get rid of these. I'm going to highlight all of this, right click on the green up here and hit delete, and that deletes all of those, all of that text. There's only one more piece of text I've got to delete, and that is the PLA that's stuck behind the group three, sorry. So I'm going to just delete that. And I'm going to go in here and highlight all three columns and go up here to the home key and hit center. And now I've got all of my data centered here. So this is exactly the form I need to run this analysis in Excel. So I only had to, not too much trouble doing that in using the text to columns conversion feature. So let's go and now let's run the single factor ANOVA as we were instructed to do in the question. And so first of all, you should have, when you click on data, you should have, or you need to have, excuse me, and you need to have the data analysis module available to you. And now, if you don't have that available to you in your computer, you should be able to go over here to File and all the way down to Options. And in the Options feature, go all the way down to Add-ins, which is the next to the last menu item. And when you click on that, you'll see Manage Excel Add-ins. So you want to go over here and click Go. And if you do not have the Analysis Toolpack available to you, those boxes will not be checked. They'll be blank. So in order to get the data analysis tool available, just click on Analysis Toolpack and Analysis Toolpack VBA and OK. And that will give you access to the data analysis module in Excel. So I can go now to data, all the way over here to the right where it says data analysis. I'm going to click on that. And the ANOVA modules are the very top modules in the data analysis toolpack. So, and we're asking this question to run the ANOVA single factor test. So I'm going to highlight that, hit OK. And this is what the menu looks like when I open it up. So I'm going to have to input the input range first. Click a few other buttons here, set a few more things up to get this ready. So if I click input range, for this test, the input range is going to be all of the data highlighted in this way. And so when I highlight all the data, I'm going to hit enter. That's my input range. It is grouped by columns. The groups are 1, 2, 3, grouped in columns 1, 2, and 3. I've also selected my labels in the input range. So I'm going to click labels. I always click my labels so that my labels will translate into the analysis when it's completed. Now let's go back and check our question to see if we were given an alpha level. It doesn't look like we were. This question does not say run the test at a certain confidence level. So I'm just going to use the 95% confidence level for this analysis. That's the default confidence level in Excel. And so alpha equal 0.05 is the 95% confidence level. I could change it if I wanted to, but I'm just going to run it at 95% since that's the default level. And we weren't asked to do it at a certain alpha level. And finally, we click output range. There's several options to where we want to put the data. I'm going to put this data right here in the worksheet by hitting output range. And I'm going to hit the arrow and I'm going to go here to F. Let's put it in F2. And that'll put my data in the cell F2. So now I'm ready to run the test. I'm going to hit OK. Oops. Let's do that again. I think I messed up my input range. Sorry about that. Let's go back to input range. I sure did, didn't I? Let's go back and reselect the input range correctly. And this just goes to show you that you have to have these selections done perfectly or Excel will return an error. So that's my input range done correctly. I'll hit OK, and here's my analysis. So let's go in and expand these columns so that we can see the entire analysis. I'm going to go between the F and the G. I'm going to start there, double click, and that expands the F column. And I'm just going to do that for each column all the way over till I get to the final column, which would be column K and L. There we go. Let's expand this one a little bit just to make that a little bit bigger. There we go. So here's my single factor analysis. And so we have our summary table here. And so in this question, if you were asked this question in this way, you would just input or copy your summary table there along with your ANOVA table. So we'll go back to the Excel sheet. And so here's where we want to go to analyze the results. So in this ANOVA table, we have the critical value of F, and we have the F statistic that was calculated from the data, and we have our p-value. And this is what we want to use to interpret these results. So the p-value we see is 0.2049. I'm going to say 0.205. And that tells us that the p-value of 0.205 is greater than our alpha level of 0.05. So we cannot reject this null hypothesis. So I'm just going to go down to this cell here, and I'm going to just write a couple of sentences to interpret these results. And so I'm going to start it like this. I'm going to say, since the p-value is equal to, and I'm just going to say 0.205, which is greater than alpha equal 0.05, we cannot reject the null hypothesis. And so we conclude that there are no differences in the three means tested. Okay. And so we can expand that analysis a little bit further. If we go back to the question that we were asked in the problem, the question says, is there sufficient evidence to support the claim that women in different age categories have different mean blood pressure levels? So I'm just going to copy that. I'm going to use it right in my interpretation of this data. Go back to my sheet. I'm going to go here. I'm going to copy that right in here. And I'm just going to reword this a little bit. I'm going to say there is insufficient evidence to support the claim that women in different age categories have different mean blood pressure levels. So that's my conclusion to my hypothesis test. So generally, when we do a hypothesis test and we draw our conclusions, a couple of sentences in this format is usually what we want to write to determine to conclude the results and to state our conclusions. Categories have different mean blood pressure levels. Okay, so we'll notice that oftentimes when we're running an experiment, we have